Okay, so this is a continuation of the previous lesson. It's still 6.9. It says find all unknown values for the given right triangle. Now, I went through and I saw that D and E helped me label my triangle. The rest of them, I'm actually going to have to find based on the information that they gave me. So looking at the first one, alpha, which is this angle here, they want you to find alpha. Now, your job is to figure out through either the Pythagorean theorem, like over here. Remember, whenever you have a right triangle, your tools are your Pythagorean theorem or your trig ratios. So looking at alpha, which tool are you going to use to find alpha? Now you think, oh, Pythagorean theorem. And yeah, you can use Pythagorean theorem, and that will help you find C. So we'll do that in a little bit. But right now we're trying to look for alpha. And so what you're thinking about is, or I guess what I want you to be thinking about is alpha. What did they give us? So here they gave us the opposite and they gave us the adjacent. And we don't know the hypotenuse. Again, the adjacent is the one that's next to the angle, and the one that's opposite is the one that's across from. So always kind of draw that angle in there. I don't know. I even pretend that this is an eyeball. Do you guys all see my eyeball here? And he's looking at side A. I know that's kind of weird, but that's how I remember. So which trig ratio, sine, cosine, or tangent, is related to opposite and adjacent? And so you're like, sine, no, because that's opposite over hypotenuse. Adjacent, no, cosine, no, because that's adjacent over hypotenuse. So it must be tangent. So over here, I'm going to write the tangent of alpha equals to opposite, which is 12 over 8, which equals to 3 over 2. So I'm just going to simplify that right off. And then if you remember, since alpha is stuck inside of tangent, you're asking yourself, how do I undo tangent? And the way we undo tangent is by taking the tangent inverse of both sides. So I'm going to tan inverse both sides here. And I'm going to squash them in here because I can. So then these two will undo each other, tan and tan inverse. So all you're left with is alpha equals to tangent inverse of 3/2. Okay, so that's your answer. So we write tangent inverse of 3/2. And whatever that is equal to, that's what you write. So I'm gonna, oops, that's not what I want. I wanted this. So I'm gonna plug in tangent inverse, which is right here. You can also type it in as in TAN shift 6, which will get you to the negative first. And we don't ever call it that. We don't say tan to the negative first. That's incorrect. So here's 3/2, and we get 56.3 degrees. And I put the little approximate, not the equal sign, because now we're rounding. And whenever we round, we want to tell people that we've rounded. So we use the approximate symbol. If it was equal to, like, let's say your teacher said, give me the exact value. This right here is actually your exact value. Because the moment that you plug it into a calculator, now it's an approximate. Okay. All right. So now what I want you to do is I want you to find beta using a similar tactic. I want you to find beta using a similar tactic. So then you're like, okay, well, beta. So I'm going to have to erase this opposite over adjacent because that's not beta's opposite. That's not beta's adjacent. And you're thinking, well, I still don't have the hypotenuse. So that probably means I'm still going to use tangent. And that's exactly right. So tangent of beta equals to opposite, which is 8 over 12. So then if you solve this, again, you would tan inverse both sides, right? Tan inverse, just squashing them in there. And then you'll notice that these two undo each other. So you're left with beta equals to tangent inverse of, and I'm going to leave it as 8 over 12 because I know you know how to simplify. And that's going to be your answer. So the exact answer for this is going to be tan inverse of 8 over 12, which is approximately tangent inverse of 8 over 12 is 33.7. So what I like to do is I like to put those angles all back in here and see, oops, I'm using my gold, oh well, and see if this actually fits this triangle. Now, if you see here in this triangle, we have 33.7, 56.3 degrees, and 90. And if you add all those up, those should equal to 180. So let's see if that does. 33.7 plus 56.3 plus 90. Yay, it's 180. And now I'm really happy because I just checked my answer. And usually, so just so you know, my favorite thing about math, the reason why I like math is because I can always check my answer. And I like checking my answer because I like being right. Right? So on a test, I'm going to use these different methods to verify that my answer is correct, therefore ensuring that I'm, demonstrating my learning, and then grade always follows the learning, right? So, Ms. Shelton, did I have to use tan inverse to find beta? No, you could have used the triangle sum theorem, like the moment that I had 56.3. But again, if I'm looking for an exact answer, that's going to be my exact answer, tan inverse of 8 over 12. Okay, last but not least, I'm going to find C. And C, you can use sine, you can use cosine of alpha or beta, or you can use the Pythagorean theorem. So I'm actually going to use one of them and use the other to check my answer. Because again, it's very valuable to check your answer. So I'm going to use sine, just so you guys get more practice with it. But yeah, probably easier to use Pythagorean theorem. But again, I want to demonstrate to you so that you feel very comfortable with it. So I'm going to go sine of alpha equals to A over C. And then I'm going to plug everybody in. So I get sine of, 56.3 degrees equals to A, which is 12 over C, which I don't know. Now, whenever he's on the denominator, whenever your variable is on the denominator, there's a couple different ways that you can solve it. I've shown you how to solve it by multiplying both sides by the denominator. There's other different ways. If you look at a proportion, now this is my little proportion here. There's some properties that are pretty interesting. Okay, so I'm going to use numbers just so that you believe that it's true. So if I go, let's say 2 over 4 is equal to, 6 over 12. Okay, that's a true statement because both of them are equivalent to half. Okay. One of the things that I could do with a ratio and see if this is true is I can make them, or not a ratio, but a proportion, is I can make them do a handstand. And so when I say handstand, I mean the bottom goes to the top and the top goes to the bottom. Now see if that's true. Is 4 over 2 the same as 12 over 6? And you're like, yeah, they're both equals to 2. So how does that apply to this over here? Well, if I make them do a handstand, then it makes it, like I can actually see it. Another thing that I could do, so I'll just call this handstand. Another thing that I could do is I can switch the places of things that are diagonal from each other, right? Not across, but at diagonal. And that'll help me in this one too. So I can switch diagonals. This has to do with a couple of things, but I won't explain it right now. So I can switch 2 and 12. So it'll be 12 over 4 equals to 6. Wait, did I say that right? Yeah, it's 12 over 4 equals to 6 over 2, which both of them equal to 3. So you could just pick whatever, kind of thing that you want. If you don't remember those, that's not a big deal. You would just solve it like normal. But I'm going to switch these two. And if you're like, Miss Johnson, these aren't proportions, I'm going to just divide by 1. And now it is, right? So I'm going to switch sine of 56.3 and C. If you don't believe me, you can multiply by the denominator and then divide by sine of 56.3, and then you'll see it comes out the same. So this is C equals to 12 over sine of 56.3 degrees. And then all I have to do is plug it into my calculator. So I'm going to plug this into my calculator. So let's put 12 divided by sine of 56.3. And some of you are like, Miss Johnson, you never checked if it was in degrees. I was using my calculator earlier, and so I knew it was in degrees. But good checking. So C is about 14.4 units. And actually, you know what? I have to say, because I was using that approximate of 56.3 degrees, I should have been using, this should have been approximate the whole time. So I think my answer is about 14.4. So I'm going to put that here. Okay. Oh, and then it's meters. And then I'm going to put that back into my triangle and see, does this make sense? Does it make sense for a right triangle to have legs that are 8 and 12 and a hypotenuse of 14.4? And to me, it does, because the legs have to be smaller than the hypotenuse, which is good. It is. And then I'm just going to use the Pythagorean theorem just to check. And the reason why I want to check is because, again, I want to just verify my answer is right. And some of you connect better with the Pythagorean theorem. So I also have that in mind. I want to make sure that you know how to use the Pythagorean theorem as well. So 8 squared is 64 plus 144 equals to C squared. So what is that? 208 equals to C squared. And then here, I'm going to square root both sides, and this is plus or minus whatever the answer is, equals to C. So remember that whenever you take the square root, you also have to take the plus or minus, because that equation, C squared equals to 208, is asking you, hey, what number can I square? And it'll give me 208. And so if you think about it, I can square a positive and I can square a negative, and it would result in a positive. So let me break this down. This is what, 104 and 2, and this is 50, oops, not 52, 52 and 2, and then this is 26 and 2, and this is, sorry, I should have thought about a better number, but that's okay. And then that's stuck. So I got a pair of twos, oops, didn't circle that right. So I got 2 times 2 root 13. So that's 4 root 13. That's my exact answer for C. And I'm going to cross out that negative because, as you know right now, you cannot have a negative side of a right triangle. And I say right now because later on you will, but it's not really talking about the length is negative. It's more talking about the direction. And I'm just going to verify that 4 square root 13 is the same as my 14.4, which it is. And if you look, these two approximations here are close, but they're not the same. And that makes sense because this was an approximate. And so if you approximate off of an approximate, you're getting further and further away from the answer, even if that further is like, what is this? 1,000th away. Okay. Which may not be a big deal in our math class, but if you all become engineers, that's your margin of error. It actually does matter. So again, look at this problem and decide, are you comfortable with choosing which sine, cosine, or tangent to use? Are you comfortable with that? If you're not comfortable with it, what my suggestion is write them all out. Write sine of alpha equals A over C. and you're like, I don't, how many variables do I have in that? If you're comfortable with that, then good. That means you're better. Are you uncomfortable plugging into your calculator? Well, if you're uncomfortable with that, just practice. So these are all things that you're not going to be good at in the very first try. And that's in general how math is, right? You didn't ask your parents or whoever helped you learn how to count. Did I learn how to count on the first try? And the answer most likely is going to be no, because I remember my daughter being like, actually, I remember this cute little video, and the little girl is adamant. She's like, I don't know, 2 years old. She's like, 1, 2, 3, 5. And her dad's like, it's 1, 2, 3, 4, 5. And she looks at him and she goes, 1, 2, 3, 5. And she's little. So, so no, you did not count perfectly on the first time, just to let you know. All right. So Benita and Andrea started, this is from the context of before, started talking about all the ways to find unknown values in right triangles and decided to make a list. What do you think should be on their list? Be specific and precise in your description. For example, use trig ratios. For example, trig ratios is not specific enough. You may use the following sentence frame to assist you with helping with your list. Now, there's a bunch of them that you can write. I'm not going to write them all, but I'm going to write one with you. So let's talk about this one. When we were looking for alpha, they gave us 2 sides of a triangle. Okay. They gave us 2 sides of a triangle. So when given 2 sides of a right triangle, right, you can find the blank. And how did we find alpha? So you can find an acute angle, right? You can find an acute angle by using, let's see. So because they gave us, let's see, they gave us opposite over adjacent. So here I'm going to be specific, and instead of writing sides, I'm going to write legs. When given 2 legs of a right triangle, you can find an acute angle by using the tangent inverse. Okay, which is, to find the tangent inverse. Now you could do this again. You could find, if you are given 2 angles of a right triangle, how would you find the third, right? And so on and so forth. So there's a bunch of them that you can write. I'm interested in seeing what you write. Go ahead and put it in the comments, and we'll see how many we can actually get, right? Okay, so it says, part 3, angle of elevation and angle of depression. During their hike, Andrea mentioned that she looked up to see Bonita. In mathematics, when you look straight ahead, we say your line of sight is a horizontal line from the horizontal if you look up. The angle from the horizontal of your line of sight is called the angle of elevation. Likewise, if you are looking down, the angle of horizontal to your line of sight is called the angle of depression. Okay. After looking at this description, Andrea mentioned that her angle of elevation to see Bonita was 23.5 degrees. They both agreed. Bonita then said that her angle of depression to Andrea was about 66.5 degrees. Andrea agreed that Bonita was describing an angle of depression, but said that Bonita's angle of depression was also 23.5 degrees. Who do you think is correct? Now, again, whenever you have these angle of depression, angle of whatever, make sure you draw a picture. Okay. So I already showed you the picture in the other one. So let's pretend this is the line of sight here. Okay. And then remember that, they're on some kind of hill. Okay. So maybe that's too sharp of a hill. Hold on. Let's make that. So they're on some kind of hill like this, maybe. Yeah, that looks good. So so when I forget who's on the bottom. Let's see. Andrea mentioned that her angle, so this is Andrea down here. Okay. And she's looking up at Bonita. Let's put Bonita up here. When she's looking up at Bonita, like, right, like this, she said this is 23.5 degrees. So here's your triangle. Does everybody see the triangle? Now this is called your angle of elevation. So this is called angle of elevation because you're going from horizontal all the way up to here. So this is called your angle of elevation. That's not very good, but you see this part in here is called your angle of elevation. Okay. Now, angle of depression looks like this. It's from Bonita. This is Bonita up here. It's Bonita's horizontal. This here is called your angle of depression. Okay. Okay. So who is right? So Bonita says her angle of depression is 66.5 degrees, while Andrea says that her angle, Bonita's angle of depression is 23.5. So let's do some calculation here. So if this is a right triangle, what angle is this right here? Yeah, some of you are like, well, it's just 180. And some of you actually don't do 180. You just go straight to 90, which makes sense because you already know that those two angles, the acute angles of a right triangle, add up to 90. That's fine. Plus minus 23.5 minus 90 is 66.5. Okay, so this angle here is 66.5 degrees. And so you should also know that these two lines, your vertical coming down this way and your horizontal coming this way, is a right angle. So that means 90 minus 66.5, which is 23.5, is this angle in here. And some of you are like, oh, that makes so much sense, Miss Johnson, that these two angles are congruent because those look like alternate interior angles. And you're right, because these two lines are parallel and you have a transversal, right? Oops, my transversal is a little bit crooked. There's your transversal, right? So if you look at these lines here, these are parallel lines, right? Cut by a transversal, you get alternate interior angles. And so because we have alternate interior angles, Andrea is right, not Bonita. So your angle of depression is not from eyesight to vertical. It's not this one, right? It's this one here. That's your angle of depression. Your angle of depression, this guy here, is this angle here from horizontal to line of sight. Okay. All right, moving on. Okay, so what conclusion can you make regarding the angle of depression and the angle of elevation? I'll leave that for you. So thank you so much for listening. I will see you guys in class. Make sure you go over some of the homework problems so that you're ready to talk about it with your group. Have a great day.